Okay, so if we're just looking at these two problems, usually what's going to scream at you in terms of, hey, I'm a natural log problem versus a regular backward power rule is how the denominator looks. Okay, the difference between having a denominator raised to a more explicit power like that with 2x plus 3 all raised to the second power versus just an expression as the denominator, okay? Or if you were going to write that as parentheses, the only power you could write on there is 1. That's a really good clue that this is probably the natural log problem. Okay. So that's always something to look for. If the whole denominator is u, then that's a natural log. If it's the denominator, it's going to be u, but still raised to a power other than -1, then that's just going to be a backward power rule. So when I look at this problem number 1, I said u is going to be 2x plus 3, du is 2x dx. Okay. And that might throw us off a little bit. I want it to be a 2. This is what I want. But I got a 4. Okay. So you can attack this a couple ways. You can turn the 4 into a 2, which is pretty easy to do. Or we can pull the 4 out front and just kind of take it along for the ride and then worry about giving ourselves a 2. Okay. It's all going to work out the same way. It's just a matter of how you think about it. Most of the time, if students can sort of see it happening, they're like, oh, I have a 4, I want a 2. A half on the inside will make that work. A 4 times a half, or 4 divided by 2, will make this all equal to 2 dx. It's just whatever I end up putting on the inside, I have to put its reciprocal on the outside. This is definitely different. We're used to putting a whole number on the inside and a fraction on the outside, and we've done lots of problems like that over and over and over and over again. It might be that you may have a number on the inside that's not what you want. Okay. If you think about, I want to take 4 times something and end up with 2, okay. That means that something has to be 2 over 4, or 1/2. So here's my integral. I'm going to put an extra 1/2 on the inside. I'm going to put an extra 2 on the outside to make all my substitutions work perfectly. I'm going to grab all of this. I'm going to throw it on another page. Oops, I don't want to make it all weird. Okay, so that means this is 2 u to the -2 du. Is this a natural log problem? Is this a natural log problem? No, because natural log problems are u to the -1 or 1 over u. So u to the -2, this is not a natural log. This is just backward power rule. 2 times u to the -1 divided by -1 plus c. Since it's indefinite, we don't have any definite numbers to put in. We're not doing fundamental theorem. We are going to go back to our x. So how about 2 times 2x plus 3 to the -1, all divided by -1 plus c. Lots of different ways you can simplify that. You can make the 2 negative. You can put 1 over 2x plus 3. Any of those things will work. The original exponent is -2. Not a natural log problem. We can add 1 and get -1 and still divide by it. We're only going to have a natural log problem when my original exponent is a -1. 3x plus 7 to the -1 times 60x. That's a natural log. If I try to add 1 to that exponent and then divide by the result after I do the u sub, I'm going to be dividing by 0. So if you find yourself in the middle of dividing by 0, that's a good clue that you're probably shouldn't be doing that power rule thing. You're probably on a natural log problem. All right, so u is 3x plus 7. Du would be 3dx. I've got a 6. I want it to be a 3. 6 times something gives me 3. Once again, one of my favorite combinations, just a little bit of a half in there. So a half in there will make that work out to be a 3dx that I want. 2 right there. So this is 2 u to the -1 du. If I try to add 1, I get a 0. I can't divide by 0. This is a special case. This is 2 natural log absolute value of u plus c, or 2 natural log of the quantity 3x plus 7 plus c. That would be my antiderivative. Every time we do a quotient, it's not necessarily going to be a natural log, but it's a possibility. We know we'll have one of those when rewriting the function as, instead of a quotient, as having your numerator or your denominator to a power, your denominator to a power of -1, or having something to the power of -1, and that thing is going to be your u. Having a u to the -1 after the substitution, that's the big clue that we're doing a natural log problem. Okay, we're going to do one more of these. We're going to mix last class's lesson and this lesson together. Okay. So we'll definitely want our calculators to ultimately get our numeric answer, but let's do this for our third problem. We are going to let's do 1 to 2. Okay, we're going to do the integral from, wait, let me see this. Wait, hold on, let me make sure I'm not making the same mistake I made last time, because I don't want to try to integrate this over an asymptote or something. All right. Ready? Just relax for a second. That's the fun music to keep you entertained. Okay, no, we don't want to do that. I almost messed that up. How about let's do this one instead? Let's look at this. Okay, there we go. I like that one. We'll go from 2 to 3. That's fun. 2 to 3, and we're going to do the antiderivative of 4x over x squared minus 1 times dx. Yeah, I like it. I like it. Okay. We got a quotient. It may or may not be a natural log. But I'm feeling like it probably is because I don't have my whole denominator raised to a power. It's just, I mean, I have x squared, but the whole x squared plus 1 is not raised to a power. And for me to do a u substitution on this, if I try that for my u, if I see if I can make this as like a 1 over u du, or u to the negative 1 du, then I get that. That's almost perfect. Not quite. I'm kind of doing this extra thing with you guys for these problems today. This is what I've got separate from my u. This is what I want. To replace with my du. I want to have a 2x. I actually have a 4x. So I'm going to throw an extra 1/2. Kind of bring that in. That'll all go together as du. And an extra 2 right there. Okay. That way the 4x and the dx and the 1/2 all multiplied together. I rearrange that a little bit. That makes 2x dx exactly perfect for du. 2 extra 2 in the front. Ooh, we're going to have to change those. U to the negative 1 du. Talk to me about my limits of integration. My tennies. I got to change into my tennies here. What are, instead of a 2 and a 3, I need different numbers there. If this is going to be my substitution, right, so what are you going to get, Selena? Say that again? You plug them in for, I don't know if you're saying that. Here. Oh, okay, that's all right. Yeah, you remember you had to plug them somewhere. You're like, I gotta plug them somewhere. Where am I supposed to plug them? Remember, these are x's, and I want to make them u's. These are x things, and I want them to be u's. So I change x's into u's through my substitution definition. U is x squared minus 1. So this is going to be, when x is 2, 2 squared minus 1 with a 3. And then up top, three squared minus 1, that's going to be an 8. If you didn't practice any of that from last class, then yeah, you're like, ooh, I'm glad the quiz isn't until Wednesday, but you got some stuff to do then. Okay. Luckily, we'll have class time on Monday to kind of try to pull all the pieces together. But it'd be super helpful if you had thought about it a little bit, you know, before that class. Okay, so I got my new numbers. Big F of x. Actually, technically not big F of x, big F of u. We'll write that down. The antiderivative is going to be 2 natural log of the absolute value of u. big F of 8 is 2 natural log of the absolute value of 8, which is just equal to 8. Big F of 3 is 2 natural log of the absolute value of 3, which is just 3. So my final answer for this guy, 2 natural log of 8 minus 2 natural log of 3. If you want to just leave it like that and don't bother throwing it in a calculator, I'm totally fine with that. I actually love that answer. It's a nice exact answer. There's a lot of different things you can do with this though. The easiest one being pop the pieces in your calculator and we'll get something like 1.962-ish for the answer. 2 natural log of 8, 2 natural log of 3, because I realize when the u sub is all said and done, u to the negative 1 turns into, antiderivative turns into natural log of u. Students usually can go one way, 2 ways with this, if one of 2 ways with this when they make a mistake. They either over apply this and they think, oh, everything's a natural log now. Nope. Or they completely forget about it. They're like, okay, she told me that thing, but I'm just going to pretend. And so that's actually probably the better thing to do. If you apply this all the time, if there's 5 problems and you apply this to all 5 of them, probably 4 of those 5 are wrong. If I'm giving you 5 problems to do on a quiz, maybe one of them is a u sub that is a natural log. So if you're going to try to apply this to every problem and turn every problem into the natural log of u, you're going to be really wrong on more problems than not. If you forget about this, you'll miss this problem, but you won't miss the other ones. You'll do backward power rule over and over and over again, and you just might illegally try to do backward power rule here, or you might just like, I'm just going to put the 8 and the 3 in here. I'm not going to take the antiderivative. U to the negative 1, you got to change that into its antiderivative before you do any plugging in. Best case scenario, you remember that it's a possibility and you watch for it to jump out at you, but you don't think every problem involves this. Okay, so in some ways this is easier than the other thing we're going to do because it's really just recognizing one special case. But it can hide. It looks like other things a lot of the time. The other kind of problem we're going to do with E, I think is easier because it's much more obvious. You don't know these are going to end up as natural log answers. You just kind of, because of the way the problem is set up, you end up with this. For the E problems, E's there from the beginning. So let's go ahead.